But exercise caution if you're entering it like digitally, like a lot of companies do, because you can only enter usually a number, like an actual number value, so you wouldn't be able to specify that you listed milliamps rather than microamps, right? So the problem would be if you see like 2 milliamps, right? 3 milliamps, and then and then the next line says 2,000. You know, wait, that doesn't sound right. Otherwise, one phase not much farther off. So make sure you're at least consistent with your units. When it's handwritten test forms, yeah, you can actually specify if you didn't convert. But as always, you know, your best practice, and you'll definitely get ahead in this industry and avoid mistakes if you get very, very good in your unit conversion. Continue practice. So let me finish up talking about here. Right, what else are we seeing?
Some shit.
Yeah, so the return mode, the ground.
I know.
And so we don't need to get too much into that, but that's going to be dictated by your test configuration, right? But for us, we're going to use the.
Where's the guard terminal?
So it's how it internally, and there are a couple charts rather that will tell you how to set up your test depending on what you're testing, and it's going to be the internal way. For example, we know the guard terminal on the Mega will subtract out the value that it reads, right? So this has a similar capability, but it would depend on your test configuration. We're going to keep things simple, keep it on the ground return mode, right? Because we're looking at, and we know we're good because we're looking at our face to ground. Right? So the ground return will be our sensing pad for the leakage current measures. A good question, yeah. And we can talk about that if, depending on the time and how the lab goes. So we have our load return. All right, okay, I'm gonna draw your attention to main power, right? Our high voltage on and off, and then our output and out, right? So I counted out how many, that's three different ways in which we control energizing this equipment, right? And for those of you who were on Tuesday, you'll remember that we want to make, barriers of entry, right? Or basically to guard ourselves from inadvertent energization of accidentally hurting ourselves, right? So if you bypass all three of these, components in order to begin the test, then you know that you're in control, right? You know that you have the specific interest of energizing this circuit, especially to the tune of 28,800 volts, right? You better be sure. Just like the Mega has a built-in button where you have to press and hold it for a few seconds. You're not going to trip and fall and zap somebody down the line for 5,000 volts, right? The same deal here.
You can't
the
turn it
idea
this
is
way?
that you have the specific intent to push tens of thousands of volts. And so you're going to have to
just
turn
lean
the main
it.
power. You're going to have to enable
Just
the high
lean it,
voltage.
like-
And then you're going to crank it up from 0 to where you got to go. While watching the needle to make sure you keep out of the So a couple other notes. When performing this test, right, we don't just crank it up, right? We have to actually slowly ramp up our voltage while carefully watching our amps. One thing you'll notice is that the amps, with every increment, might tend to shoot up, right? In some instances, depending on leakage current, you could be set at the lowest scale, and it could already top out at 1, which means that you actually need to change your scale, right? So what you thought might have been
Put it down.
in the milliamps could be tens of milliamps, right? So you have to be able to, and especially the more you practice and you know what's going on in this test set, be able to determine when is the right moment to change your unit, change your current multiplier, in order to make sure you're still getting good readings, good numbers. So when we perform the test, right, the values we're interested in are going to be the milliamp, microamp, whatever they can failing, right?
Yeah.
Or failing these boxes.
No,
Right.
it's fine.
Because this is a go, no go test, right? If it withstands, remember dielectric withstand test, we know it withstands the voltage is subjected to it, we know it will therefore pass, okay? Now, in broad numbers, if you see, 5, 10, and 300, right, is that alarming? We do not, and that's kind of what it alluded to, right? So there's a 50% rule we know is associated with which test? Right? So remember, the numbers don't necessarily matter in terms of how close they are to one another, right? Exactly. If it does not, if it breaks down, dielectric breakdown, right? The test set will actually shut off. push it past a certain point, and in that case, we'll have passed or failed. It will fail, because in that case, you don't even get your leakage current number, right? It'll be way off scale at that point, right? Okay, so say, B phase passes face to ground, but it fails line to load, what would you put for the final, determination? Fail, yeah. So if it fails any of these tests, yeah, it fails all, yeah. Basically, a fail in any of these configurations is a fail for that particular test, so, yeah. And in that case, you know, you deliver the test with A and B phase, failed the data withstand test. In some cases, we've had, you know, I'll give you an example, we had a failed bottle, vacuum bottle, and they swapped out that bottle on the spot. And then we were able to retest, and then it actually helped, right? And by that case, yeah, after that it passed, vacuum test. So, this is gonna be our goal for today. In order to fill out this test form, you already got one freebie right there in the top left corner. Hopefully you're following along enough to remember where this came from, how we got that, right? And from there we'll proceed to, because we have 6 different configurations, obviously I'm gonna be leading at least the first one, and if people are so inclined, and again, you get hopefully get more out of this class than what you put in. But if you know, for example, you're interviewing a heating company, to be able to tell them that you operated a high pot to 28,800 volts, we think that's going to